Good day, everybody. This is Chris back again at the Ancient Scholar, and today what I'd like to do is I'd like to give you an example of receptors in action, and we'll kind of pull back and continue looking more big picture. And I want to focus on a type of a somatic nervous system receptor. So somatic, all right. And the somatic nervous system, as we talked about, involves a skeletal muscle. And the primary neurotransmitter of the somatic nervous system is acetylcholine, or ACH. So if acetylcholine is involved, then we know that that is going to be a cholinergic receptor. All right, we know that it'll involve a cholinergic receptor. And we know that if it involves a cholinergic receptor, it's probably going to fall into one of two types of receptors, either the nicotinic or the muscarinic variety. And if you remember talking about nicotinic versus muscarinic receptors, we knew that the muscarinic receptors were located in organs and glands and caused increased gastric secretions and increased mucus production secretion in the lungs and so on. And then we said that nicotinic receptors are often located in muscle tissue. This could be smooth muscle, could be cardiac muscle, and as you have no doubt have probably guessed at this point, it would also include skeletal muscle. All right. And if you remember, the muscarinic receptor is the response, the intracellular response is a G protein coupled response, whereas nicotinic receptors, their response they are ionotropic versus the metabotropic muscarinic. And so the nicotinic receptors are ligand-gated ion channels. And the particular nicotinic receptor of the somatic nervous system that I'm going to talk about actually has a special name, and that receptor exists within an area known as a neuromuscular junction. All right, a neuromuscular junction, and you may hear the term end motor plate. Okay, end motor, as in a T there, as a tango, end motor plate, or motor end plate, as some people may say. This is synonymous. These terms mean the same thing. And the neuromuscular junction is a junction where the somatic nervous system is what we call innervates, where the nerve actually interfaces with the skeletal muscle. So what I'm going to do is I am going to kind of draw the somatic nerve here coming down. All right, so here's my somatic nerve, and so this is the axon, and then we're going to kind of talk about the terminal of the axon here, the nerve, like so. And then I'm going to have, this is my muscle now. Maybe I should just make that in a different color. Let's just do that. Let's make the muscle a slightly different color so we know what we're looking at here. So here's the muscle. All right, and here is the junction. All right, so there we go. So I have this junction in here, and of course the generic term for a junction between a nerve and a nerve and a gland, a nerve and a muscle, nerve and an organ, etc. The general term is what we call a synapse. And the general term for this, we can also call this what's known as a synaptic cleft. But the specific term that we use to identify the synapse between a somatic, maybe I'll just label this here, a somatic nerve and the muscle that it's innervating, of course, we call that the neuromuscular junction, the NMJ. And the NMJ is nothing more than the synapse between the somatic nervous system and the muscle that it's innervating. Now, in this junction here on the muscle part, and I'm going to draw these in a different color, I have the actual nicotinic receptors, okay? And of course there are different subtypes of nicotinic receptors, and we won't get into them, but these are a subtype called nicotinic M, I believe, for muscle. But here I have my nicotinic, so I'll just label those as my nicotinic receptors. All right. And the primary neurotransmitter associated with the somatic nervous system is acetylcholine, is ACH. And of course, you probably guessed that it'd have to be acetylcholine because nicotinic receptors are cholinergic receptors. So you have acetylcholine, and I'll just label these here as ACH, acetylcholine that exists within little vesicles within the terminal, the ending of the axon here. And so what happens is, let's say that, I make a conscious decision to maybe pick something up, that nervous impulse is going to make its way down the neuron here, okay, and of course that nervous impulse is an action potential. It's an action potential. So I have sodium. The cell membrane is depolarizing, so I have sodium rushing into the cell, and potassium is leaving the cell, and the membrane potential changes, and that action of sodium going in, potassium going out, just kind of moves all the way down here until it gets to the terminal end of the axon. And then right here, once that impulse gets here, I have little channels here in this area, and this impulse causes their conformational changes, and these what we call calcium channels open up, and calcium rushes into the cell here, okay, and that then causes the acetylcholine vesicles. The acetylcholine vesicles will then move out of the neuron, and they are secreted, and then the acetylcholine is released into this cleft here, and of course the acetylcholine will make its way to the nicotinic receptors, and the acetylcholine then attaches to the receptors. And remember, we also said that the nicotinic receptors are ionotropic. Specifically, they are ligand-gated ion channels. So what's going to happen is the acetylcholine is acting like a ligand. It is a ligand, and it'll attach to the receptor. It'll induce a conformational change on those receptors, and those receptors will then open up. They will open up, and they will allow a specific ion to then flow or rush into the muscle cell here. And the specific ion is the sodium, okay? So those receptors open up, sodium then rushes into the cell, okay? So here I'm just drawing these black arrows here, signifying that now sodium is rushing in through these channels, through the nicotinic receptors. And what happens when sodium rushes into the cell? Well, that causes, if I have enough of it rushing in, that'll eventually cause this muscle to depolarize. Okay, it'll cause the muscle to depolarize. And so basically what I've done is this action potential here, I'm causing an action potential here. That's what a depolarization is. And I'm depolarizing the muscle by opening these channels up. And of course that depolarization then leads through several other steps several other intracellular processes that leads to muscle contraction. And I'm able to contract my muscles. So this is just an example of a bigger picture scenario involving nicotinic receptors with the somatic nervous system, and we'll probably talk about a few other different scenarios that are important physiologically, but I thought this would be a good one to talk about. Okay guys, as always, thanks for hanging in there.